Okay, now it's recording. If Davidson gamma used 100 volt to accelerate electron beam instead of 54 volt, what is the wavelength of the electron? Okay, question 9. Use 100 volt. This V2 instead of this V1. So what is the wavelength? Okay, actually, to find this wavelength, you don't need the V1. You just need V2. Yeah, you want to find V2. Wavelength is lambda 2 lah. Okay, so you just use the formula lambda equal to h over cert 2 MeV. Okay, wavelength. So you can find already. You can find the wavelength. Just put in 6.63 negative 34 over 2 mass of electron is 9.11 negative 31. Okay, negative 31 mass of it, and then electron charge 1.6 negative 19, and then V is 100 volt. Okay, 100 volt. 54 volt, no need. Yeah, no need. These extra questions, no need. So I get the lambda wavelength of electron. So wavelength of electron is 0.123 nanometer. 0.123 nanometer. So you have to change. You either can put nanometer or you put in SI unit meter, but that one got exponent. Okay. 54 volt no need to use unless you want to do comparison between 2 and 1. Okay, and lambda 2 with lambda 1. But right now we don't need to find lambda 1, so we just focus on lambda 2 using value voltage V2. Okay, now question, let's look at question 10. Yeah, let's look at question 10. So question 10, so you have electron and proton, all these mass extracted from rest by the same potential difference. Okay, so again, this one got 2 columns. One is electron, one is proton. So they are same voltage V, voltage E equal to voltage P, same voltage. Alright, de Broglie wavelength. So you have lambda E, lambda P. De Broglie wavelength. So okay, so now want to find ratio of lambda E to lambda P. So that means lambda E over lambda P lah. You want to find class. So in terms of this, so okay, let's do it. Lambda E over lambda P. So okay, so I can put lambda E over lambda P equal to remember the formula lambda equal to h over cert 2 MeV. Use this formula. So you can this lambda E, if lambda E, then is h over cert 2 MeV. This one is for electron over the h over cert 2 MeV at the bottom. Okay, class. So and then I can cut off already the rest. This one, 2 and 2, cut off different. Oh, this one is mass of electron charge. Okay. And then voltage is also the same. You see that? This one, he said initially he said the voltage is the same. Same voltage. I always remember this one. Same voltage. So same voltage, I can cut off the velocity also, the voltage also. So it's just left with what, class? Electron charge. Electron is the same charge because the charge of one proton is the same as one electron. Understand? So the charge also can be cancelled off. So just left with what? Just left with over, so this is a mass of proton over mass of electron. Okay, So this mass of proton go to the top and mass of electron go below. Okay, so that's the answer. Let's find out the answer. Is it correct? Number 9, 0.123 nanometers, correct. Now how about lambda E over lambda P? Lambda E over lambda P. So I got cert mass proton over mass electron. Mass proton over mass electron. Mass proton over mass electron. That's correct. Mass proton over electron. Proton over electron. Okay, that's all for these questions. Very simple. If you want to put in value of mass of proton, put in value mass of electron also can. You can find the, then you can straight away find the ratio of wavelength electron over proton already. Okay, what I mean is you put in the value here. See, mass of proton is 1.67, mass of electron is 9.11. But since the question asks you to find in terms of mass electron and proton, so no need to change the value lah. Okay. So that's all. The answer is correct. Yeah, if I compare with the answer scheme, mass of proton or mass of electron, cert is correct. Lambda E or lambda P, that's correct. Okay, that's all. Bye.